definition. An alternative pathway for the oxidation of glucose. The major function of this pathway is to produce D-glucuronic acid, which is required for detoxification of foreign chemicals and the synthesis of mucopolysaccharides, MPS. This process do not produce ATP, but is utilized for the generation of activated form of glucuronic, which is UDP glucuronic. In certain animals, this pathway also produces ascorbic acids. This pathway always occurs in cytoplasm. Next, we move to the metabolic steps. First, it starts with glucose. Then, the glucose is converted into glucose 6-phosphate. It uses glucokinase as enzyme. It also uses ATP to form ADP. Then, glucose 6-phosphate is converted to glucose 1-phosphate. It uses phosphoglucomutase. Glucose 1-phosphate is converted to UDP glucose. The enzyme used is UDP pyrophosphorylase. It also uses UTP to form TPI. Then, UDP glucose is converted to UDP glucuronate. It uses UDP glucodehydrogenase as enzyme and also uses 2-NAD+, which is oxidized to 2-NADH plus H+. UDP glucuronate is converted to D-glucuronic acid 1P. The process is called phosphorylation. D-glucuronic acid 1P is converted to D-glucuronic acid. It uses glucuronidase enzyme and also it uses H2O to form UDP. Then, D-glucuronic acid is converted to L-gulonic acid, which uses LGDH. L-gulonic acid is converted into two products, which is L-ascorbic acid and 3-ketogulonic acid. L-ascorbic acid is used L-gulonolactone oxidase enzyme, while 3-ketogulonic acid use beta-HD. Then, 3-ketogulonic acid is converted to L-xylulose. It uses beta-keto-L-gulonate decarboxylase enzyme. L-xylulose becomes xylitol. It uses xylulose reductase. Then, xylitol becomes D-xylulose. It uses NAD+ to form NADH and H+. Then, D-xylulose is converted to xylulose 5-phosphate, which use xylulose kinase enzyme and use ATP to form ADP. Lastly, xylulose 5-phosphate become HMP shunt, which is our final product in this metabolic steps.